Hello, thanks for having me. My name's Andrew, and today I'm going to be talking about avoiding catastrophic outages. If you're attending this talk, you may have been impacted by a catastrophic outage in the past, or you might be looking at preventing that from happening to your organization in the future. So, we're going to look at common causes and ways that open source technology can help mitigate those problems for you in the future. So I work for an organization called Mattermost. We provide secure collaboration for technical teams. And throughout the presentation, I'm going to be talking some about what our platform can do. So we're going to talk about the different features involved. But first, I just wanted to show you kind of what the interface looks like so you can get a sense of what this type of application looks like when I say secure collaboration. We're talking about tools we know and we're familiar with, like chat, but we're also talking about things like playbooks, which you'll see on the right and we'll talk about later, which are automated workflows, and also things like project management. And so, beyond just Mattermost, I myself, my name is Andrew. I'm a developer advocate. And before working in developer advocacy, I actually used to work in education. I used to be an English teacher in Japan. And the catastrophic outages that I dealt with on a day to day basis were of much lower stakes. But I've applied a lot of what I've learned in the classroom to now being working in developer advocacy and equipping engineers with the tools they need to be successful. A little bit about Mattermost as well, in case you're not familiar. We are an open source project. We have over 800 global customers that use our platform, but within our open source community, we have over 30,000 different line code contributions, over 4,000 open source contributors, many GitHub stars. We've been translated into languages all across the world, and we're deployed all across the world by different types of teams. And so we love our open source community. We wouldn't be possible without them. And a lot of the technology we've built has been done so with the help of our open source community. So before we move into the topic at hand and a catastrophic outage, I think it's important that we make sure that we are on the same page about what is an outage, and we talk about the scope of what that looks like. And so to do that, I want to tell you a story about a catastrophic outage that actually happened. And this was in July 2018. And what happened was there was a fire in Paris that knocked out an electrical substation. So this caused a widespread power outage. It disabled railways, and it cut off powers to businesses, schools, hospitals, homes, and ultimately it took 3 days for all of the power to come back online. So this widely impacted the country of France. And the organization that manages France's power grid is called RTE, and they have a large, complex system that they have to manage. You're talking about over 100,000 kilometers of power lines crisscrossing all across the country that have to be constantly maintained and repaired. All of this is supporting a $3 trillion economy. It's easy for us as consumers to, or as everyday people to just be used to electricity being a light switch. You just turn it on and you get electricity. But it's easy to take that for granted. Power itself is actually a very complex technical task to manage. You have to balance dynamic power consumption with the actual supply of energy. Wind and solar are affected by the environment. Nuclear takes more time to heat up than coal, which is a faster moving energy. And all of these things have to be balanced with actual power consumption, which changes from hour to hour. So going back to the grid from earlier, that's talking about a huge, massive input of information. You have all of the power coming in, all the power going out, and it takes a lot of technical tools in order to have this under wraps. And so RTE didn't have something like Mattermost in place that kind of facilitate this. Classically, they were doing it with different tools they had available, and the result was a disjointed communication, and that's what caused an outage, and it took time for that type of thing to be repaired. And when we talk about the impacts of those kind of outages, it's easy to just be to talk about the financials. As oftentimes where we hear about outages is how much revenue was lost, how much downtime that actually cost us, and how much it has impacted our organization in terms of money. But an outage can also impact the public's security impression of your organization, their ability to trust you, especially if you hold personal information or you're an information broker for them. If you are otherwise compromised with their personal information, or are not trustworthy as a source of information, then you're kind of tarnished in their eyes. So the impact of that outage can be to your reputation beyond just your finances. And sometimes we don't necessarily take this into consideration, but depending on the types of tools that you work on as an engineer, oftentimes, we work on low stakes projects that are just used on the internet or to facilitate a certain task economically, but sometimes the things that we work on are mission critical. They're high stakes and they're deployed in environments where they cannot fail, and if they do fail, people's health and welfare could be on the line. So those are the stakes that we're talking about when we talk about outages and the impacts of them and how we measure them. And so the outages that occur in these types of environments, like going back to our earlier example with the electrical grid, that's complex. And the complex environment is going to require the people working in those environments to have specialized tools. And all of these outages that occur across these different types of orgs, they're different, but they often have the same kind of root causes. One of them that's very common is they're exceeding their limits as a system. They're pushing their networks, their actual servers, their vehicles, their personnel to the limits. They're absolutely taxing out everything available to them. And this introduces a possibility for human errors, for actual component failures, right? And especially when you have these large sprawling networks of machines and things that are interfacing, oftentimes no matter how complexly rich and cross-integrated they are, there are still single points of failure where maybe if there's a certain server that goes offline or a certain person that's not available, things fail. And so that's what can cause an outage. Another thing that can cause an outage is seeing these things and understanding them, but lacking the ability to communicate them or contextualize them for your team. And this creates blind spots. Maybe you understand that there's an issue affecting your team, but you don't understand how it affects a larger scope of things and is actually part of a larger problem. And if you don't have that cross-team communication, then you can't identify those systemic problems before they become deeply rooted. Another thing that it happens within failure to mitigate is not planning for failure. It's obviously easy when the lights are on to say, but why do we need the plan for when the lights are off? But when you do have that plan in place, then you don't have to navigate building that kind of roadmap while you're in the actual crisis. Having a contingency plan beforehand and having the infrastructure to support that plan is critical to minimizing an outage if it does happen. And another cause of outage is something like a malicious attack. This is something purposeful by another organization or a third party. This is something like maybe a DDoS attack on some of your servers, or something like internal sabotage, data compromise, or loss. These are things that can cause outages within your organization or ultimately cause downtime. So going back to the complex environments, we've now talked about the different types of problems that stem these outages within these complex environments. Now, how do we solve them? We give them the tools that they need to thrive. And we do that through secure collaboration for technical teams. And you heard this earlier. That's what Mattermost is. Secure collaboration for technical teams means that it's trusted. And our platform is open source, like I mentioned. You can fully audit it. Any security personnel within your organization can understand what Mattermost does and look at how the data, look at how their own data can interact with our application. And because we're used in so many high stakes environments by so many personnel and organizations that use us in high trust, high secure, mission critical environments, we achieve a high level of security because we have all of these organizations auditing our software. And if it's good enough for them, it's likely good enough for you too. And another element of this is that our platform is flexible. It's fully extensible from top to bottom. And that's the beauty of open source and a big reason a lot of people love open source. You can deploy it yourself and control all your own data. You can deploy it in the cloud with us. And then you can, along the way, you can alter all of the elements of it, the back end, the front end. You can add plugins, apps, /commands, webhooks. And as you do this, you're able to integrate it into your own organization's custom security and compliance protocols. You can make it work for however your organization is deployed. Going back to if you're maybe on your own network or you're in some kind of specific security protocol. And finally, this secure collaboration platform provides something that's workflow centric. It provides tools where the work is done. It's a hub for your technical teams. It gives them the context and the access to the systems that they use every day. It's common, especially when we talk about technical teams, to think about engineers. And even within just the example of engineers, there's a lot of technical tools that they use. You have things like Jira and GitHub and GitLab and Jenkins and ServiceNow and Notion and all of your project management tools. And these are all different tool chains, and they're all needed at different stages of working, and you need to understand what's going on them in order to do your job. And that's what a workflow centric environment facilitates. It allows you to customize it and automate it to your own needs, because we're recognizing that we have technical operators on our team and they need flexible and customizable tooling that's specific for their workflows. So all of that is encompassed within Mattermost. What we've talked about are things that you do within Mattermost. And Mattermost has been employed within those organizations, like we talked about before, like RTE, in order to facilitate those goals. You know, you have it on desktop and you have it on mobile. People that are out tending to those 50,000 kilometers of power lines can see the real-time updates, the same as the operators back in the command center can control everything and communicate. So in order to really understand why this is important, I want to tell a story about back in the early 2000s with Microsoft Outlook. And Microsoft Outlook now is something that's ubiquitous. And we think of it as just email, right? It does email. But Outlook at the time when it came out was actually revolutionary, and it hinges on a particular concept because it took these disparate tools that were analogs of their office components, their in-person office components, and it combined them. You have things like the email client itself for sending and receiving the mail. You have the rich text editor, and you have the address book, which had all of your contacts, as well as a calendar for figuring out your appointments. And before Outlook, these tools were separate. Just like how when you were sitting in an in-person office, you had your calendar in front of you on your desk and your address book and your Rolodex and maybe your mailbox out by your front door. So there's all these different components that then had their computer analog, but it was clunky. Outlook took all of this and combined it into one mail platform. And now that's just what we think of as mail. And now we think of when Gmail, it has all of these features and other mail providers, this is the standard for mail. And the same thing is happening now with Mattermost. Mattermost is taking the types of tools that developers use, and it's combining these common workflows, these common contexts that they are in, into one platform. Because now we just think of it as, oh, Outlook's where you go to write an email. Mattermost is where you go to do your work. It has your audio and screen sharing options because it has in-app voice calling with your teams. And then you can have a plugin for making Zoom calls from Mattermost. It's going to cross-communicate with all of your other messaging apps, whether that's IRC or Slack or Microsoft Teams or Discord or Matrix or what have you. It's going to have integrations for your project management tools. We already have popular plugins that we maintain for things like Jira. And you can also connect with your source control like GitHub and GitLab. And then finally, and we're going to talk about this more in a moment, is you have tools for incident management. These are things like ServiceNow and understanding, what are the problems facing my organization and our platforms, and how are we responding to things in the moment. And we're going to talk about that in just a moment. So diving into some stories from our customers and from use cases and people who have used us, one thing where Mattermost really shines is that it meets the standards needed for a mission critical scenario. Other tools are too general purpose, and this is something we hear over and over again with the people we work with. And this in particular is about a space agency. They send rockets into space regularly, and they do so through Mattermost as their command and control center. A general purpose tool wouldn't cut it for them. They need something fully extensible and secure from top to bottom. They have to they cannot compromise the security of their actual launch platform, but they need the flexibility to build in all of their tooling. Here's another story that is very common. We talked about security so far, and about securing your data, but this is actual physical security. This is securing personnel and people, coordinating real-time travel domestically and internationally with VIPs and high-profile individuals. This is something that's really well facilitated on something like Mattermost because you have the apps for people that are out in the field. You have the people back have all the information at a command center coordinating people, and everybody can confer with the same exact source of information, have the latest in real time, and no one's ever acting on stale information. And because the line is secure, it meets those critical security needs that you would have to have for this type of scenario. And similarly is using Mattermost to respond to things like natural disasters. And natural disasters are like a real world outage in a sense. You have teams in the air and on the ground and back in operational buildings that are facilitating all of the relief efforts, getting personnel on site. And this is a situation that's rapid and evolving and has to have a day zero response in order to minimize impacts of the problem. And so this is a type of outage scenario, a continual kind of outage avoidance scenario that Mattermost is employed with, because it helps people on the ground. They can utilize it in real time wherever they go to fix the problem, but then they can also standardize these workflows over time and help make everybody safer. Another instance where we're used is actually in the U.S. Air Force. So, when planes go in the sky in the U.S. or the Air Force, they do so through Mattermost. We are their command and control center for getting planes in the sky, and really the reason that we're there is because we solved a problem for them, similarly to how we solved problems for RTE, the electrical grid. Within actually the Air Force, there were critical like time crunches for when personnel would arrive on base and when they would get their mission information and get on their airplane and get in the sky. So you're talking about personnel that are arriving for like air missions, and they're not knowing what they're doing or where they're going until they're on the base and handed the details. And this is a security concern, obviously, because they don't want to have all that information on different networks outside of the base. So where Mattermost comes in is it allows them to deploy Mattermost within of their military network. They can use it within all of their strict security protocols. This is the U.S. Air Force we're talking about, and they're able to integrate their digital flight workflow into Mattermost. And now instead of everybody having to crunch the flight information and ask any questions and get geared up and ready within just 30 minutes, which it's introducing human errors and causes for outages going back to earlier. But now we're allowing more time for this process to happen. We're reducing the stress on the system. We're reducing the chance of human error, and we're going to reduce flight delays and operating costs. Nobody's idling on the tarmac waiting for the all clear and burning thousands of dollars in jet fuel every minute. That scenario is resolved because they can use Mattermost to be more efficient. So through these, we've learned a lot of lessons, and these are something that are summed up in an acronym called MRI, and I'm going to walk through them. So first, M is monitor, R is resolve, and I is improve. And these are the three pillars that we employ, and especially that we talk here at Mattermost about resolving incidents, and it's going to be a part of what we're going to end on today. So first, talking about monitoring, this is referring to observability and alerting and escalation within your platforms and your services. This is having tooling like Grafana and Prometheus, looking at the actual statistics for your deployments. You can actually pull this information into Mattermost. So here's a snapshot of a demo that we have with ServiceNow, a very popular incident management, incident resolution platform that you can integrate into Mattermost to do exactly like this. You can monitor your services, get real-time alerts, and also be able to check on the status from within Mattermost bidirectionally because you can integrate them. And once you understand that there's a problem and you've escalated it, now you're moving on to resolving it. Mattermost is assisting you with this step as well. It's giving you the protocols. Those are the standardized checklists that we saw earlier to resolve a problem. It's allowing you to adapt those in real time to meet the needs of a situation. Give status updates to stakeholders because everybody is in the same collaboration platform, and then finally triage it with the information gathered and delivered. So here's an example from the same kind of demo within ServiceNow. We have a playbook running, so you have your checklist over here on the right. It has the steps that we need to do to solve this issue. This is something that was maybe created beforehand by an SRE or otherwise facilitates specifically for my organization what I need to do. It has things like slash commands that are on here, like buttons I can click, and it's just as if the same I typed it down here below. So you get like a full featured chat channel that contains all of the communication around this particular incident. You get the checklist of step by step what happened, when it happened, and who did it. And then once this is over, you have a way to improve moving forward. And that's the I in MRI. You have a way to analyze, retrospect, and sustain what you've built and learned so far. So now going back to the same demo, you're able to fill out a retrospective report where everybody can report back to management, leadership, stakeholders about what went well, what went wrong, what can we implement moving forward to prevent this issue. And what it does is it allows your organization to evolve beyond meeting the needs of these issues and more into not having these issues at all. You're addressing the root of these causes. You're going back to, how can we mitigate outages? It's through this practice, by having insight and oversight into how your actual technical teams are operating. So now that we've talked about all that, I just want to end with a little information about how you can employ this information moving forward. If any of this is interesting to you, or if you want to learn how to mitigate disaster using something like Mattermost. Again, we're an open source platform, and we're a tool of choice by many top global leaders in all sorts of different fields, particularly around security and technical collaboration. We have a lot of clients like in the military and the government, but also in finance and in healthcare. Think about things where data security is of a very high priority. Those are the kind of customers whose needs we meet and whose outages we prevent on Mattermost. So if you want to learn more about our platform and get connected with us, here's a QR code that you can scan now at home if you want to grab these slides. I can make them available later as well. And these are my socials, as well as the information for the Mattermost website and YouTube that you can contact us on. I'd love to hear from y'all if you have any questions at all. But particularly if you have any desire or questions about this presentation or about following up, I just encourage you to reach out to me at this email here at continuity@mattermost.com. We can definitely get back to you about your questions from there and assist you. But I look forward to having more conversations, and I hope everybody has a great time at Developer Week. So thanks so much.